And here are some problems that we're going to do that for. Find the inverse and state the domain of each of the following. Okay, so we start off with this nice linear function. A linear function has an all-real domain as well as an all-real range. Right? The graph goes completely from the left, off, and up and down in every direction, so there is no restrictions on the domains or the ranges for an inverse. And the inverse function for a linear is going to be another linear. Okay, so what we do is you switch the x and the y, right? So y and f of x are the same, so you put x over here equals 3y plus 2. Right? You switch the x and the y in your equation, and now we solve for y again. So all that wonderful algebra that we do to solve this equation for y, right, we'll subtract 2 from both sides. X minus 2 equals 3y. And we'll divide by 3. Okay, now there's lots of ways that we can write this. One of them is simply x minus 2 divided by 3. That is a fine way to write your answer. We could write it as 1/3 x minus 2. Same exact thing mathematically. We could write it as x divided by 3 minus 2 divided by 3. There are lots of ways that we can write this linear equation. But either way, we have to set it equal to y inverse. Okay, this up here, this is what y equals. These down here, this is what y inverse equals. So make sure you are using the notation y inverse when you are done with your equation, right? This is not equal to y, this is equal to y inverse. So put the -1 notation up there to represent y inverse. Or since we had f, you could write f inverse as well for this also. Okay, just to differentiate it from maybe g like we're going to do here in a second. So our first step in this is to switch your x and your y. So if this was your y equals x squared minus 9, the first step in finding the inverse is saying x equals y squared minus 9. And then we do all of our algebra, all of our procedures and steps in order to solve this for y again. So we'll add 9 to both sides. X plus 9 equals y squared. And now we're going to take the square root. Now, when we do this for an inverse, we have to take the positive and the negative of x plus 9 equals y inverse again, or g inverse, since this is the g function. Maybe g inverse would be more appropriate. Okay, the positive side and the negative side. Okay, and let me show you why in case you don't know. So the graph of y equals x squared minus 9 has a -9 y-intercept and a +3 and a -3 x-intercept. Okay, and it looks like this. Now what we just found out was the inverse is the square root of x minus 9. Okay, now just like this, we have a x-intercept of -9. But remember, it's just the positive side. So the positive is this top stuff, right? This is positive root x plus 9. Sorry, minus 9. I digress, minus 9. So that's the positive side of the root. So you also have to include the negative side of the root, right? This is the negative of root x minus 9. So whenever we're doing this algebraically, you have the positive, which is the top side of your sideways parabola, and we also have to include the negative for the bottom side of your sideways parabola. So when we're doing this algebraically, you have to remember that there is a plus and a minus of the root. Don't just make it the positive, because that's not the complete picture. The complete picture is the top and the bottom, the positive and the negative. Okay, H. This is probably the trickiest one, algebraically speaking. There's lots of things you have to remember. But the first one is switch your x's and your y's. So we're going to put x on the left and then 2 over y plus 1. So our y value is in a denominator. You have to remember, how do you move things out of a denominator? There's only one way, and that's through multiplication. So we're going to multiply both sides by the entire denominator, right? You don't just get to multiply by y and have it be good. The whole entire denominator has to be multiplied by in order to get rid of it. So the y plus 1 is now multiplied by x on the left, and that equals 2. Okay, now I know that your amazing brains want to distribute. You want to, because you've been taught this. Whenever you have parentheses, distribute. Well, don't do that here, right? Because we're not trying to figure out anything over here. We want to get y by itself. So we're going to want to get rid of x first. And how do we get rid of x now? Divide both sides by x. Okay, so resist your temptation to distribute. 2 over x. And our last step is to, subtract 1, not add 1. Subtract 1. And where does that subtraction go? After our fraction. So 2 over x minus 1. Okay, this would be the equation for the inverse. So every time we have a rational function as our graph, or as our function, h is a rational, right? It has an x in a denominator. The inverse of a rational is a rational. Okay, you're always going to have a fractional inverse if we start off with a fractional inverse. Okay, our last example is t. It is a root that also has a power, but the steps are still the same. We're going to replace x and y. We're going to switch them. So x equals the third root of y squared. So the first thing we have to do is get rid of this third root. And how do we undo a third root? By raising it to the third power. You undo a root by raising it to that same power. So we have x cubed equals now y squared. Okay, because the power and the root cancel each other out, and you just have y squared. So our last step is going to be to square root the y squared. Okay, and now you don't have to have a plus or a minus because this doesn't quite work like that. So we're going to have the square roots. So do we need to have a 2 out there? No, you do not need to have a 2 out there in the elbow. If you want to put one there, fine. But when you don't see one, you are to know that that is the second or the square root. And then finally, don't forget about your inverse notation, right? Y to the negative first. Okay, this is y inverse. Y inverse, y inverse, to separate yourself from your first thing, which was y. Okay, so number 1, switch your x and your y, and then solve for y until you get to the end, and then you make it y inverse. And that's how you find your equations. Today we're talking about inverses of functions. So some things you should know about inverses of functions. So let's say we have a nice graph like this graph right here. Okay, it might be some type of a parabola. You never know. It could be a fourth degree. It could be a second degree, but we'll call it a second degree just for fun. Maybe y equals, I don't know, x minus 1 squared minus 4. How about that? That's a nice looking function right there. May or may not be because we don't actually have any tick marks. So what we want to do here is decide, right? How do we decide if a graph is in fact a function? Well, there's something called the vertical line test. And you draw a vertical line through your graph at any point. And you notice how often that graph touches the vertical line. Okay, and if that graph only touches the vertical line once, then yes, that function, or that graph, is the graph of a function. Now, if you drew the horizontal line, okay, the horizontal line test, okay, we're asking the same thing. Does that graph get crossed by that horizontal line more than once? And in this case, hopefully you see that it does. So in other words, the inverse of this, of y, will not be a function. Okay, it can exist and it will be a nice graph, but it will not be a function. Okay, so some things to remember, right? If you have a graph, you draw the horizontal line test, and if it fails, right, if it crosses it twice, then the inverse will not be a function. Okay, so we could perform some domain restrictions, right? What if we erased the right half of this graph, or rather the left half? What if we erased this graph right there? Okay, and we only talked about this graph from +1 to infinity, right? What if we restricted the domain to +1 to infinity? Now, would the inverse be a function? Yes. Yes, it sure would be, because this part, right, the right side of this graph, only crosses a horizontal line once. Okay, so this one would in fact be a function. The inverse of this would be a function once we do some domain restrictions. So some other things to know about the domains. Okay, so the domain of this function, now that it has a restriction, is from +1 to infinity, because I made it like that, and your book might make it like that. Okay, that's where that axis of symmetry is. So you get a nice pretty half of the graph. And the range of this function, do you know how to find the range of this function? The lowest possible y value? Well, that's reassuring. -4 to infinity. Okay, of course, when you plug in, well, this part of your graph tells you what the vertical shifting is. So you take an x-1 graph and you move it down 4 units. So that means the range has been moved down 4 units from its parent function. So what happens when you take the inverse of this, the domain and the ranges switch. Okay, the domain of your function becomes the range for your inverse. And the range for your function becomes the domain of the inverse. So if you can find the domains and ranges of your original function, then finding the domains and ranges of your inverse are pretty easy. Okay, they're just switched from what they used to be a second ago. So if we had a square graph, a quadratic, the inverse of a quadratic, hopefully you know, is a square root. Okay. So another thing to know is the inverse of a graph is the reflection across the line y = x. So the graph of this inverse would look something like this. Right, so the blue thing would be the graph of the inverse. It's -4 to the left, right? That's the domain of this inverse function. It has a range of 1 to infinity, right? So here's your lowest value at +1, so the range goes up. The domain goes to the right. And you always have this nice intersection of these two graphs on the line y = x. So these are some of the things we should have remembered and use all the time in Algebra 2. Okay, you would have done many, many problems where you had to look at these things and evaluate them and figure out all this stuff. Okay? We are just going to look at the algebra for it.